All right, so this is the next type of question they're going to ask. What's the area enclosed by the inner loop? So they're just looking for parts that you need to find the area from. So what you're looking for is starting and stopping values. So we already know we're going to have the integral of 1/2 and then 1 plus 2 sine theta squared d theta. It's just how much of this area do we need? We're just plugging our r in. So if you look at our Desmos graph of this, it moves around like this. And then the red is what we're looking for. So if you look at the inner loop, the red that we're looking for here, the inner loop, is we want to find out when does it start and stop. And that's when it equals 0. You can see that we're at 1 here, right? And then it goes all the way back around and then hits 0. And then it does the inner loop and then hits 0. This is r. So radius 1, 0, radius 0 again, and then back around. So we're looking for those two zeros. So we're going to take this and set it equal to 0. So when does r equal 0? That will give us our start and our stopping. So we want this right here, this little inner loop, to find its area. And that's when our radius equals 0. So it's going to give us our starting and stopping. So this would be -1 equals 2 sine theta. So -1/2 equals sine theta. So when does -1/2 equal 2 sine theta? So our theta is 7 pi over 6 for your quadrant 3 and 11 pi over 6 for your quadrant 4. Remember, it makes those two little inner. So if we go from 7 pi over 6 to 11 pi over 6, we'll get what we want. Now you can also go from 7 pi over 6 to 3 pi over 2, which would be that halfway point, or from 3 pi over 2 to 11 pi over 6. We're going to keep both of these. Okay, so let's work this out. So we end up with 1/2, and then it's 1 plus 4 sine theta plus 4 sine squared theta. So again, we're going to get that double angle of, I'm going to just wait on this until we finish. So we have 1/2 plus 2 sine theta plus 2 sine squared theta. All right, now we can use our cosine, right, our double angle. So we have 1/2 plus 2 sine theta plus, and then it's 1/2 of this, but it's already got the 1/2, the 2, so it's going to cancel nicely. 1 minus cosine 2 theta. All right, and then the 1 and the 1/2 make 3/2. All right, now we are ready for our integral. So you can see all we're really doing is just changing what we plug in, starting and stopping values. So we have 3/2 theta plus, oops, now going to be minus because it'll be cosine. And then minus, and this is 1/2 sine 2 theta, 11 pi over 6, 7 pi over 6. Again, it's a cosine. So when we take it, the integral would have been sine, and then derivative of sine 2 theta is going to have a 2 on the outside, which cancels with the half. All right, so we have 3 over 2, 11 pi over 6, minus 2 cosine of 11 pi over 6, minus 1/2 sine. And then we do the opposite, so minus 3/2, 7 pi over 6, plus 2 cosine 7 pi over 6, minus 1/2, so now it'd be plus 1/2. All right, so this is just going to cancel and make a 3. Same thing here, 7 pi over 3, 11 pi over 3. All right, and then we need to make that coterminal here. So think about 11, that would be 5, because you would have 6, and 7 would be 1, so just pi over 3. Okay, so now these two would cancel. So we have 11 pi over 4. And then on the bottom, they would cancel as well, giving us 7 pi over 4. And then we end up with minus 2. And then cosine of 11 pi over 6 is rad 3 over 2, minus 1/2. And then sine of 5 pi over 3 is negative rad 3 over 2. And then down here now we have plus 2. Cosine of 7 pi over 6 is negative rad 3 over 2. And where are we at now? 1/2 of sine of pi over 3 is rad 3 over 2. Okay. So we end up with, this would be 11 minus 7 is 4. 4 over 4 is pi. And then now we have to add up all the rest of them. So cancel, 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 cancel. So we end up with negative rad 3 and negative rad 3, which would make negative 2 rad 3. And then over here we have negative, negative, so it's rad 3 over 4, rad 3 over 4. So it'd be plus rad 3 over 2, because you're going to get 2 and 2, right? Sorry, 1 plus 1 is 2, 2 over 4. Okay. So now we put these together. That's a half and a negative 2. So pi minus 3 rad 3 over 2. And there's our answer, I hope. Let's go back now and check. That's a lot of little errors. This is why we get to use a calculator to verify this. So second calc, math. And then we're going to do math 9. And we go from 7 pi over 6, so 7 pi divided by 6, to 11 divided by 6. And we plug in our 1/2 parenthesis. Squared. So we have 1 parenthesis in parenthesis parenthesis, perfect. D theta, hit enter, and then we go, okay, well that looks good. Let's find out. Second pi minus 3, second square root of 3 divided by 2. Cross your fingers. It's good. Yeah. So there we go. So approximates are nicer because you just plug this in your calculator, but you can see with the exact, we're doing the same thing over and over and over again, which is kind of a nice little twist, right? So again, we're looking from 0 to 0 on this problem. So if we check those numbers that we found, which we haven't yet, it would be 7 pi divided by 6, and then to 11 pi divided by 6. So you do want to plug them in, and you can see it shaded it perfectly. And then with the t, we could do the same thing just to verify it. 7 pi divided by 6, and then ending at 11 pi divided by 6. And if you hit play, you'll see it goes right around our loop exactly the way we wanted it to. So that is what we're looking for, from here to here, so that our integral will add up just that part for us.